Hey guys, I hope you're doing well. So we'll continue talking about congruence today, and congruence is the idea that things are the same shape or the same size. I want to commend those of you that finished your work from yesterday, and I encourage those of you that have not yet to please get on it and make sure you finish it, because we are going to be more strict with late assignments this semester. So I think all of you yesterday answered correctly that two shapes or two figures are congruent if they have the same exact shape and the same exact size, right? This is very important. They have to be the same shape and same size for you to use the word congruent when describing the two shapes. So maybe just a quick question. If I have these shapes here, say 1, 2, 3, 4, 5, and 6, if you can pause the video and try to figure out which of them are congruent. Well, I hope you can see that these two are congruent, and I think these two are also congruent. I think this and this are the same shape, but they are not the same size, so that means they are not congruent. So please don't make that mistake. So just a recap of what you guys found yesterday is that congruent means two objects have the same shape and the same exact size. Has to be the same exact same. What? Same exact same. Anyways, same shape, same size is congruent. The symbol that we use, so today we're going to go into the symbolism and how to write congruent statements. The symbol that we use to mean congruent is these three lines. It's like an equal sign, but you add an extra line there to emphasize that everything is equal. Because the normal equal sign is just two lines, but the third one there is just to show that it's congruent, exactly equal. However, when we're writing congruent relations, it's very important that the vertices or the points or the corners or the order of one figure corresponds to the vertices of another figure. So these two triangles are the same exact shape and size, and you can see that easily when you try to rotate them. Right? If I rotate this triangle to kind of make it look like the other one, and if I was to reflect it, how do I reflect? If I was to reflect it, let's see if I can reflect order. I don't know how to reflect it, but if you were to reflect this, you could be able to see that they are the same exact shape and size. Never mind. They are the same exact shape and size, so they are congruent. But when we're writing the congruent statement for these two triangles, it's very important that we follow the same order of the vertices. So I hope you guys can see that vertex B corresponds to vertex E in this triangle, right? Then from B you go up to A, and in this triangle from E you go up to F, right? And then the last one is going to be D. So when I'm writing ABC here, right, if I'm writing ABC going from A to B to C, let me use corresponding colors. B is E, F is A, and D is C. So when I'm writing the congruent relation or expression for this triangle ABC, I cannot, I have to say, since this is ABC, then in this triangle it will have to be FED, right? FED, triangle FED. This is the only way that it's correct, right? If I write ABC and then here I write DEF, that is not correct. That is not a correct congruence relation because I did not follow the same ordering of the vertices. How this makes sense is, imagine someone gives you directions that go, go straight, take a right turn, take another right turn, right? And then take one left turn, and then it's the third gate on the left, right? Those are the correct instructions. They said go straight, take a right turn, take another right turn, left turn. Now, if these same instructions are given to you in reverse order or out of order, if someone, because this is one right turn, another right turn, and a left turn. But if someone had said, oh well, you go straight, you take one left turn, and then you take two right turns, well, that is not going to get you to where you're trying to go, because those instructions or those directions have not been given in their correct, precise, exact order. So that's why it's important when you're writing congruent statements for relations relations between two figures that we keep the order of the vertices the same. So you guys go ahead and finish this. What if this triangle was BAC? If I wanted to write the congruence for BAC, what would that be? You guys go ahead and finish this, and then submit your answers as part of your notes. So you guys go ahead and finish this. And then we also have these ones here. Again, write the congruence relations for these triangles. I'm just going to do one, then I'll ask you guys to do the others. I'm going to do this one over here. So have X, Y, and Z. Step one is figure out what, because you have two triangles. You have X, Y, and Z, and then you also have X, Z, and C. Now in these two, it's easy because in the second triangle that goes from here down to C, these vertices X and Z are already aligned. So I hope you can see that I just need to bring the C. The C is the same as the Y. So I can just write, if I write X, Y, Z, that has to be equal to triangle XCZ. XCZ, right? I hope you can see that. And then in this one here, this vertex is the same for both the triangles, right? And I hope you can see if I twist this triangle like this, if I twist it in that motion, and then I flip it onto this one here, I hope you guys can see that vertex F is the same as vertex R, and vertex E is the same as vertex S. If you twisted it, imagine twisting it and then flipping it back onto the other one. So therefore, DEF must be equal to, if I go from D and I go to E, that means in the other triangle I'll go from D to S to R, triangle DSR. So you guys go ahead and complete these two, right? This one over here and this one over here, and still submit them as part of your work for today. Now one thing that we can get from congruent shapes, or something that is cool that can come from congruent shapes, is so many different interesting patterns. The simplest one is over here, which is a pattern created just by using triangles. I have 1, 2, 3, 4, 5, and 6 triangles, and they are all congruent, the same shape and size, and I've used them to create a hexagon. Here I hope you can see these are just arrows, right? Arrows that are the exact same shape and size but different colors, and they've been used to create this interesting pattern. These are Lego pieces that, exact same shape and size, again, interesting pattern. These are, I think, kangaroos or very interesting goats. And these, I don't know, looks like starfish or arrows again. But congruent shapes were used to create patterns. Now obviously in some of these, some of the arrows are facing on the left, some of the arrows are facing on the right, but they're still the same shape and size. And tomorrow we'll talk about this idea of, how they can face in different directions and still be congruent. That idea of transformations, we'll talk about it tomorrow. But what I want you to do today for your homework is I want you to create a cool pattern using congruent shapes, right? A cool pattern using congruent shapes. Now you can use, I'm going to post something on your Google Classroom where you can use this drawing tool, and you can find any image you want. I looked up donkey, so if you want, you can use an image of a donkey. You can copy the image, and then you go to your shape and paste it, right? And all you have to do is paste many images and just put them together. However, I want you to have different orientations. I want some of them to be rotated like this, some of them to be facing, some of them to be reflected. What do I mean by reflected? So this one, let's see if I can reflect this. So I can rotate it, or I can, some of them I want them to be flipped, and some of them I want them to be rotated. So the objective of this activity is that you create a cool pattern using similar shapes. So you can find any similar shape online. You can even Google cool congruent patterns, right, and find inspiration. All of these things exist out there, I don't want you to copy an image from Google and use it. I just want you to use this for inspiration, and then find one little image, one little thing, it can be whatever you want, and use it to create a cool congruent shape that you're going to submit. If you don't want to use this drawing tool, you can use something at your house and draw it on a piece of paper. Let's say you have a Lego piece, and then you go and draw that Lego piece on a piece of paper, and you draw that same Lego piece a bunch of times. If you're using paper, make sure it covers at least half the whole piece of paper, and I don't want there to be any gaps or spaces in your drawing. For example, something like this, if you had this and there are gaps like that, that is not okay. If you're using this drawing tool, the whole thing must be covered, right? The whole thing must be covered, so you'll need to figure out a way to readjust them such that they are fitting perfectly and they are still the same exact shape and size. So yeah, that's your activity and that's your homework for today. Tomorrow we'll talk about transformations and see what those mean in the context of congruence. All right, bye. Let me know if you have any questions.